Here's another example using undetermined coefficients. And this is our first example where we've seen an exponential in f of t. We've dealt with polynomials, we've now dealt with one involving sine, and if you had one involving sine and cosine, you would do it the same way as the last example. But now we have for the first time e to the 5t, or e to the something times t. So it's our first example of that. It doesn't change much, the process is still the same, and I'm sure you would expect that our particular solution would have that same form, meaning the same coefficient of t in the exponent. So it shouldn't surprise you that we're going to have y sub p be a e to the 5t. Notice it looks like the same structure, only the coefficient is the undetermined part. Right, so again, the process is the same. We find y prime and y double prime. Y prime would be 5a e to the 5 of t. Y double prime is 25a e to the 5 of t. And so when we substitute those in, we start with y double prime minus 4 times y prime minus 12 times y. And all of that equals 3e to the 5t. So again, notice that every one of these terms has e to the 5t, so really we're just equating the coefficients. So here I'm going to have 25a minus 20a minus 12a all has to equal 3 on the right side. So the coefficients of e to the 5t on the left all have to combine to equal the coefficient on the right. And it's very simple. Setup, 25 minus 20 minus 12 is negative 7. So a is just negative 3/7. Which means our particular solution, the full version, is negative 3/7 e to the 5t. As before, we can talk about, in passing, the homogeneous solution. So this one, y double prime minus 4y prime minus 12y equals 0 if we did the homogeneous solution. I'll leave it to you to note that the values of r you could get from that would be negative 2 and 6. So yh is c1 e to the negative 2t plus c2 e to the 6t. So the full solution looks like c1 e to the negative 2t plus c2 e to the 6t minus 3/7 e to the 5t. Now I want to make one note here very briefly that's going to come back in a few minutes later on with a different video. Notice that the three pieces here all have the same structure, e to something times t. It just so happened that this one is different than both of these, right? So we have e to the negative 2t, e to the 6t, and then e to the 5t. So this one doesn't match either of the original ones. However, we'll do an example later on where this does turn out to be the same as one of the originals. In other words, if the original problem had e to the 6t on the right side instead of e to the 5t, or it had e to the negative 2t on the right side, then this would come out to look like one of these two terms. Now the reason that's a problem is, as we've talked about before, these solutions, for superposition to work, these solutions have to be linearly independent. So this can't be the same as one of the other terms. So we'll talk about later what to do in the case where that happens, but you may see those examples every now and again where when you start to solve this, your solution comes out to look like one of the homogeneous ones. So we'll talk about how to recognize that and then what to do when that's the case. So that'll be in the later example video.